we are picking back up. We're ready for number 4, I believe, in lesson 8.2. Talking about particle motion. So, what do we have here? A particle is moving along the x-axis with velocity given v of t, measured in meters per second after t seconds, with an initial position of s of 0 equals -3. So at time 0, the position is -3. Determine the displacement of the particle on the time interval 1 to 7. Keyword is displacement. How do we do displacement? The integral of what?
A to B of VT.
Of VT. So that means in this case it's going to be the integral of, what's A and B? 1 to 7 of, what's V of T?
T squared plus 7t.
Okay. So the integral from 1 to 7 of -t squared plus 7t minus 10. That's all we're doing on the first part. So let's integrate. -t squared
Plus 1/1/3 t.
-1/3 t cubed plus integral of 7t minus the integral of 10. I'm going to go with 10t, but yeah. I mean, you know.
I always think in X is that.
I get it. I get it. Evaluated from 1 to 7. Okay, so I'm going to plug in 7. Okay. So -1/3 times 7 to the 3rd plus 7/2 times 7 squared minus 10 times 7. And then I put that whole quantity in parentheses minus, and then it's what? -1/3 times 1 cubed plus 7/2 times 1 squared minus 10 times 1. So, how much of this can we do without a calculator? It'd be faster to do it with a calculator. What is 49 times 7?
247. Wait. 49 times 7. 273. 43. But yeah, I said 50 times.
4 times 7 is 28. Were you doing 3 times 7 by chance? Okay. Okay. So 7 cubed is 343. So this is -343 cubed plus, now, 7 squared is 49 times 7 again. So now we're looking at 343 halves minus 10 times 7 is 70. Now, we're subtracting the whole next parenthesis. I wouldn't be against going ahead and taking off the parentheses here. So -1/3 times 1 cubed, -1/3, but if you're subtracting -1/3, it's going to be adding 1/3. 7/2 times 1 squared, so I'm going to say minus 7/2. And minus -10 is going to make it plus 10. Okay. If you're doing this without a calculator, I don't know what plan of attack you would do. I know I would probably go ahead and at least put together the like pieces that I already have. So like the idea of negative 343 over 3 plus 1/3. I know that's going to be negative 342 over 3. Plus 343 over 2 minus 7 halves. What's 343 minus 7? 336 over 2. Minus 70 plus 10. Minus 60. And then I was going to say, yeah, I just looked at my notes. If you're truly using, if this is truly a non-calculator problem, you're now getting a common denominator, aren't you? Okay. So, common denominator would be 6. So, times 2 on the first one, negative 684. Times 3 on the next one, I just got 1008, minus 60 times 6, it's going to be 360. I don't know, would that be a calculatorless problem or not? It could be. I mean, she didn't put a calculator symbol on hers, so. At that point, what? It's negative 684 and negative 386. So, or 360, excuse me. So if I add my negatives, so I'm going to be at negative 1044 plus 1008. So 1044 minus 1008. $36, and that's of the negative 36 over 6 variety, which is negative 6. Negative 6 what?
Meters per second.
No, just
No.
relax.
Displacement total meters total.
Okay. Interesting enough, I have negative 6 feet in my book.
What?
Why do I have feet? I don't know. I agree with the meters. Now, what does the negative mean? I think I heard someone say it.
To the left.
It'd be 6 feet to the left of 0. Okay. Or, dang it, meters. So this would be 6 meters to the left is what your negative 6 would be in terms of displacement. Because displacement is, or 6 meters back, depends on the scenario. Moving along the x-axis, so to the left. Now, what is the total distance traveled by the particle on the interval from 1 to 7? How do we do total distance? What did we learn yesterday? Okay. You're adding all the pieces together, yes?
So it'd be the absolute value.
Okay, so we talked absolute value. Now, I want to check one thing real quick. Because I want to make sure I guide this right, and I'm a little questioning of my notes, so. It does give the same answer, so why did I do this the long way? Okay. I went about this a long way in my notes. And so what I'm looking at is, why did I do that? Does it work the short way? You just said absolute value, yes? So officially it would be what? The integral from 1 to 7 of the absolute value of negative t squared plus 7t minus 10. Oh, that's why I went about it the long way. Now, and I guess I could have, in my notes, I just said absolute value of v of t. Here's the deal. If we have a calculator, that's easy to put in, yes? Because you have absolute value bars on the calculator. If we don't have a calculator, and that's where my notes confused me from, I did this calculator list, okay? If we don't have a calculator, we don't have a way to do absolute value, really, other than looking at the graph and breaking this up, okay, into the various pieces. In other words, absolute value, some of the pieces are already positive, yes, some of them are not. And so if we're doing it by hand without a calculator, you've got to think about the graph, okay? What shape is this going to be? Parabola, right? Specifically a parabola of the upside down variety, right? Okay, now this parabola, okay, so if I factor out a negative here, because we're going to factor this, we're going to have t squared minus 7t plus 10. What does this factor into? Negative 5, negative 2. So that means we have zeros where? At 5 and 2, yes? So the idea, the reason why I'm doing this, okay, visualize your parabola, okay? Actually, I don't even necessarily need that. The idea, it's an upside down parabola, yes? It's going to cross the x-axis at 2 and at 5. Now, here's the catch. We're on the interval from what? 1 to 7. Part of this is already above the x-axis, yes? From 2 to 5, that area is already above the x-axis. It's going to be positive. From 1 to 2, and from 5 to 7, you're looking at area below the x-axis, because it's finding the area between the curve and the x-axis. So if you're doing this by hand, you're breaking this into 3 integrals. Okay? So you would be breaking this into 3 integrals. You'd be doing the integral from 1 to 2 of v of t dt, and it would be the absolute value of it, plus the integral from 2 to 5 of v of t dt, and then plus the integral from 5 to 7 of the absolute value of v of t dt. Okay? Now, the deal is, the first one and the last one are going to come out negative, aren't they? But that's why we say absolute value. So you're going to have the absolute value of a negative, the absolute value of a negative there. This guy's just going to come out positive. So you're not going to have to worry about, officially it's absolute value there. But that's the idea of what we're looking at. Now, as I look at my notes, I don't have the work, like that I worked all 3 of these pieces out. Okay, so here's the deal. If you have a calculator access, you can go straight, put the whole function in, and you're going to get the answer. If you don't have a calculator access, you've got to look for what's above the x-axis and already positive, what's below the x-axis and negative that we then need to make positive. Does that make sense?
Yeah.
Okay. Now, go ahead and do it on the calculator if you haven't already. Just the original. I'm going to put these pieces in just so we can.
Okay.
I already got it. Yeah.
What's the calculator giving you? For this right here? Did you put in absolute value? You didn't put in absolute value bars. Because -6, no, it's not. You have to put absolute value bars in the problem. Okay. -6, notice, is the answer to the problem up above.
15.00000055.
That's the calculator answer. Now, did we find absolute value bars?
No, how do I find? Where's that at?
It's,
I know they're in alpha
It's
A2.
a one of
Alpha.
I know it's in that menu.
Oh, yep, there it
And
is.
then where in the math menu, is it one where you have to go over one menu to the right?
Yeah.
Is that what it
You
is?
hit math, you just go one.
You go to num menu, and it's right there.
15.000055.
Good review. Where are the absolute value bars on the calculator, right?
Yeah, I got it.
Okay. So, by putting the absolute value bars around, what it's doing is it's taking the positive of each section and adding them. Okay. As I said, you don't have that option. You've got to manually break it into the 3 sections and make them positive. Okay. Easier said than done here. It's done. It's just work. So, regardless, you do come up with 15 meters. Okay. If you get a common denominator and add those fractions, guess what? You get 15 exactly. Okay. I hope you don't mind that I skipped a little bit of the work there, but I kind of did a little bit of both actually. Would have been easier just go straight calculator, but I didn't want to do that. Exactly. Okay. Are we ready to talk 5? Okay. So, happy face up here, right? We see a calculator symbol. We don't have to question. It's a calculator. Period. End of statement. Suppose you are driving in traffic behind a large bus at 66 feet per second. This is 45 miles per hour. When you finally get a chance to pass, you step on the accelerator, giving the car an acceleration of a of t equals 4 over the square root of t, where a is measured in feet per second, and t is measured in seconds. Okay. How fast are you going 16 seconds later when you have passed the bus? How are we going to find how fast we're going? To find how fast we're going, we're going to need to know what function. Velocity.
Integral of a and t.
Okay. Velocity is the integral of a of t dt. Okay. So, well, we're not finding the velocity on a certain interval. Okay. We're finding the velocity function so we can find how fast we're going at 16 seconds. Okay. So, velocity is going to be the integral of 4 over square root of t dt, which, if we're going to integrate that, we could rewrite that how?
T is -1.
Okay. And that 4 is just a constant, so it can technically go out front. So the 4 can be in or out of the integral, whatever. I just wrote it as 4 times the integral of t to the negative 1/2 dt. Okay, so add 1 to the power, the new power becomes positive 1/2. Dividing by that new power of 1/2, well, dividing by 1/2 is multiplying by 2. And don't forget,
Let's see.
plus c, because this is an indefinite integral. I didn't put any bounds on here. Now, continue over here. We can clean this up. 8t to the 1/2, or 8 square root of t, plus c. Okay, we need to talk about finding c, or what c is. What information do I have that will help me with that?
Oh. You're driving at 66%.
Okay. Okay. So essentially, you're driving at time 0, you're going 66 feet per second. So that is c, yes? Okay. And here's the deal. I mean, you can think of this as the ordered pair of time 0, 66, but what happens when you plug that in? 0 goes in for t, that becomes 0, you end up with c equals 66, yes? Don't always just assume that the given value is c. That can get you in trouble. But in this case, because it's at time 0, it does work out that way. And as I said, if you plug in 66 equals 8 times square root of 0 plus c, you are going to get c is 66, right? So my velocity equation is 8 square root of t plus 66. What question were we supposed to be answering?
When t is 16.
Yeah. How fast are you going 16 seconds later? So we're doing what?
8 sine square root of 16 plus 66.
Okay, we're finding v of 16. So 8 times square root of 16 plus 66.
That's not it.
98 what?
Feet per second.
Per second.
Okay.
It's not 98 miles per hour.
It's faster than 66. That's what I'll go with. Okay. B. How far did you travel during that time? What are they asking me?
Total distance.
Okay. Is that total distance? Yeah, I agree. Now, they're asking me total distance.
From 0 to 16.
Okay, yeah. So from 0 to 16. So the integral from 0 to 16 of what?
The velocity.
The velocity function. And if it's total distance, what do we technically need to do? Absolute value. Okay. So really we're doing the integral from 0 to 16 of the absolute value of, I lost my equation, 8. In my notes I wrote 8t to the 1/2 plus 66. Or you could have 8 square root of t, whatever. Okay. Oh, because it looks like I did integrate this by hand. Although we are allowed a calculator on this problem, aren't we?
Yep.
Okay. Now, and here's the deal. I integrated this one by hand because that's what I thought. Think about this scenario. What are we doing? You're driving in traffic behind a large bus. And then what do? You pass the bus. Is total distance going to be different from displacement in this case? If, right. If you're never going backwards or taking any side ventures or anything like that, in this particular problem, total distance will equal displacement, right? I'm not saying that's always true, but that is the case. So that is, you know, something to think about. Total distance equals displacement. And I'm going to say, in this situation. Okay. Okay. We probably need to keep things moving. Did you guys get a calculator answer here then?
I think so.
What'd you get?
11397.3334. Oh, 30's repeating.
Okay, 3's repeating? Okay. And that would be in terms of what? Feet. Okay. Now, the question is, what is the average velocity for the 16-second interval? There's two different ways we could do this.
Can we just add 66 and 98 divided by 2?
No.
1 over B minus A times.
Okay.
I was thinking you're going.
Did you want to 1 over B minus A?
Right. We can, okay, so as I said, there's two different ways to do this, both very legit. So we can, one option to think about average velocity is the 1 over B minus A, which in our scenario is going to be 1 over 16 minus 0 times the interval from 0 to 16 of, and I'm just going to write it as V of t dt. Because here's the deal. We're not redoing the math, folks. We have this math. 1 over 16 minus 0 is 1/16 times. Do we already know this integral?
Yeah.
Yeah. Because, as I mentioned, in this scenario, total distance is equal to displacement. So if you do this problem without absolute value, you're going to get the same answer. Okay? And so it's going to be 1/16 of the 1,397.333 value. Which is what?
87.333.
Okay. And that would be its average velocity, so feet per second. Okay. Other scenario that we could have just talked about, but it's the same exact thing, is that we could have mentioned that average velocity is going to be displacement divided by time. Okay, so your difference in position divided by time. Hey, guess what? It's going to be the same thing we just did, right? Because your displacement is that 1,397 number divided by 16. You get the same answer either way. Okay, so whichever way you think about it, that's my point there. Okay, number 6. You drop your calculus book from a window 48 feet above the ground. I wouldn't recommend that with these books. I think that could be detrimental to the integrity of your book. How long will it take your book to reach the ground? What?
What's the formula? Is it involved the formula for gravity or something like that? A rate?
So we're going to talk, let's see. Okay, so yeah, they don't give it to us here, do they?
Yes.
We're going to talk about it. Okay, so let's go through here and talk about what we know.
C is 48.
Okay, eventually there's a C that is 48. It's also what?
Initial position.
Initial position. That's where I'm going to go right now. Is that S of 0, the position of the book at time 0 is 48 because it's 48 feet above the ground, right? Okay. What's your velocity at time 0? Velocity at time 0 is 0 because what are we doing? You're holding the book, right? Okay. At time 0, you're holding the book. You haven't dropped it yet. Then we get the question of what is acceleration at time 0. And that's where we're going to talk about gravity. Now, what kind of labels are we using here? Feet. That is key because there is a acceleration for when we talk meters and there's an acceleration when we talk feet. Okay, since we are talking feet, we are using the negative 32 feet per second squared. By the way, this would have been 48 feet, 0 is 0. Okay. Now, with that in mind, okay, that's kind of your initial given information. We want to know how long it will take the book to reach the ground. If I want to know how long it'll take the book to reach the ground, I'm going to have to get to the point of having a position formula.
S of blank equals 0.
And we'll set position equal to 0, right? But I don't have a position formula to begin with. There's only one, I have an initial position, but that doesn't help there. There's only one real formula that I have right now, and that is our acceleration. You know, I just put acceleration of 0. I really should have said acceleration of t, because that is acceleration due to Earth's gravity. That's not just at time 0, that is all the time, yes? Sorry. So, what I'm going to say, we have an acceleration formula. How do we find velocity? We're going to integrate. So, velocity is the integral of acceleration. So, velocity is the integral of negative 32 dt. What's the integral of negative 32 dt? Negative 32t plus c. Now, before we can move on, we need to find our plus c. No.
What?
And as I said, eventually it's a c because 48 relates to the position.
When t is 0, 0, 0.
So the velocity at 0,
What?
the velocity at 0, so if I plug in 0, negative 32 times 0 plus c, the velocity at 0 does what? It equals 0. So what do we know?
It's just negative 32t.
Okay. And for the velocity formula, c is 0, and my velocity equation is v of t is negative 32t. Now, where am I going? We start with acceleration. We found velocity.
We need a position. So the integrate again.
Position is the integral of velocity. So position is the integral of negative 32t dt.
It's negative 16 t squared plus c.
Are you guys with them? Add 1 to the power, divide by the new power. So that's negative 16t squared plus c. Now, what do we know?
Let's see.
C is 48.
Nice.
Okay, so officially, S of 0, negative 16 times 0 squared plus c equals 48. So agreed, c ends up being 48 when you set up that equation, right?
Yep.
As I said, I agreed earlier that c was 48 eventually. Okay, you have to get to the right spot. So, what is my position formula? S of t is
Negative 16 t
negative 16t
squared plus 48.
squared plus 48. Oh, what were we supposed to be doing? Okay, we want to know, when does S of t equal 0? When does the book hit the ground? So, negative 16t squared plus 48 equals 0.
Factor out
Uh-huh.
negative 16.
What'd you say?
Factor out negative 16.
Okay. There's a couple different ways we can look at this. So, if you factor out negative 16, what do we have?
T squared plus 3.
I'm going to go with it becomes t squared minus 3.
That's what
T plus the square root of 3, t
Not a traditional factor, but could you think factoring here?
Yeah.
The other option is, could you just set t squared minus 3 equal to 0 and add 3 over?
Plus or minus the square root.
So either way, whether you're factoring, whether you're solving, you end up with t is plus or minus the square root of 3.
Now, how do you have a negative time?
Do we have a negative sign?
No.
No. So that's just what you would say is an extraneous solution. It solves the equation, but it doesn't make sense in our scenario. So t is equal to
Square root of 3.
square root of 3 seconds. Okay. Okay, B. What is the velocity of the book at the instant it reaches the ground?
Oh. Plug in square root of 3 into the velocity.
Does that make
Yes.
sense?
I think.
The instant it hits the ground is square root of 3, right? Instant it reaches the ground is square root of 3. Do we have a velocity formula? Yeah. The velocity was, what, negative 32t? So you are finding the velocity evaluated at square root of 3. You could say negative 32 square root of 3. That doesn't really make much sense of an answer, but what does it work out to be?
Negative 55.426.
And that label is,
Feet per second.
it is velocity, so feet per second. Why is it negative?
Because it's falling down.
It's falling, okay? Okay.
Oh, what?
One more problem officially. with only 4 parts. Okay.
Okay.
A particle moves along the x-axis so that its velocity at time t on the interval from 0 to 15 is given by a differentiable function v whose graph is shown below. At time t equals 0, the particle is at x equals 4. The velocity is 0 at t equals 3, t equals 9, and t equals 13. The graph has horizontal tangents at t equals 6 and t equals 11. The areas of the region bounded by the t-axis and the graph of v on the intervals 0 to 3, 3 to 9, 9 to 13, 13 to 15 are 6, 9, 3, and 2 respectively. Okay. First thing I'm going to do is reread that and make sure all the info. Oh, they already have the 6, 9, 3 on there, don't they? And 2. Okay. So, note we're talking 0 to 15, yes? So, well, it's not really marked as that's the end. You're only going up to 15. At time t equals 0, the particle is at x equals 4. So, what... We're talking initial here, and they use... Okay, so basically we're looking at x of t here. So x of 0 is equal to 4. They're using the position function as x here, is what they're doing. Okay, which you sometimes see s, you sometimes see x. That is your position function. So initial position is at 4. The velocity at t equals 3, 9, and 13 is 0. So they're saying that these are zeros, right? So that is velocity 0. Because this is a velocity graph, right? There's horizontal tangents at 6 and at 9. Okay. And then the areas of the regions are 6, 9, 3, and 2, and those are already labeled on there. Okay? Okay, let's see what these questions ask. A, for the interval 0 to 15, find the time and position of the particle when the particle is farthest to the right. Justify your answer.
X equals 3.
Why?
Because it's 6, and then you're going down 9. And then you add 3, subtract 2. So that moment in time would be
That's the farthest.
right.
Okay. So, okay. And you kind of reasoned it out in your head without, So what I looked at is I found definitely the position at time 3 is important, yes? Because right there, we've come off of our first positive spell, so to speak. Now, with x of 3, there is you do have to take this into consideration, but it would be for all of them. Technically, we have a initial position, right? The initial position is 4 plus the integral from 0 to 3 of v of t dt. Officially, that's what it would be. Now, initial position is 4. What is the integral from 0 to 3 equal to?
6.
That's a 6. So, officially, at time 3, we are 10 units to the right. Okay? Now, do I even really need to consider time at time 9? No, because you're coming off of a negative run, right? So you've just gone left. The other one that we could check would be the other coming off the positive, which is x of 13. Okay? Now, if we check x of 13, it's still the initial 4 plus the integral from 0 to 13 of v of t dt. So you've got the initial 4. When we go to do 0 to 13, you have to take into account what? Plus 6 minus 9 plus 3. Where does that position put me at? That position puts me at 4, doesn't it? So, back to the logic, the farthest right you're at is at time 3, okay? Now, here's the deal. We checked, so velocity is greater than 0 on the intervals from, what was it? 0 to 3. And is that 9 to 13? Okay. So that's why we checked those places. But what we already stated, particle is furthest right at t equals 3. And that's because we found x of 3 to be 10. Okay. Okay. Let's go B. For how many values of t is the particle at x equals 4? Explain your reasoning. Well, what do we already know?
Starts at 4.
Okay, it starts at 4, yes. And I'm going to, I don't know, I didn't make this page big enough. I have stuff to write, but I'm going to make kind of a little chart here for us just to kind of, so at time 0, it starts at 4, yes? Okay. What's the next time we know something? At time 3, where are we at? 10. Let's make our list and we'll come back. The next time we know something is time 9. Where are we at time 9? We were at 10, take away the 9, we're at 1. What's the next time I need? Time 13. What about time 13?
4.
Addie's quiz. Okay, and keep going.
13 is 4. 15 is 2.
Okay. Did you guys follow that okay? We were just adding and subtracting along the way, right? So at time 9, we were at 1. Then we added 3, we're at 4. Then we subtracted 2, we're at 2. Okay, guys. We're at 4 right there, yes. We're also at 4 right there, yes.
You gotta cross 4 between 2.
Did we have to be at 4 some other time?
Yeah.
Okay. Now, officially we need to state, though, this is a continuous function. Okay, it's kind of an understood, but we can only assume this 4 right here because it's continuous. So, how many values, how many times did this happen? 3. So, officially it's by intermediate value theorem. I don't know if that rings any bells right off the top of your head, but I'm just going to say by IVT, there are 3 values or 3 times where the particle equals where it's at 4. Okay. Okay. On what interval is the speed increasing?
3 to 6. 9 to, what's that, 11? So when they're the same, right?
Okay, so review back to yesterday, right? Speed is increasing when acceleration and velocity are the same, yes? Now, so why 9 to 11?
Because the graph is moving away from the x-axis.
Positive.
Okay, so 9 to 11, that's why they're told us horizontal tangent right here. My velocity is positive because it's above the x-axis, and acceleration is positive because there's a positive slope, yes?
Yeah.
And acceleration is the derivative of velocity. So that's 9 to 11. What else did you say? 3 to 6. And that would be because velocity is negative, it's below the x-axis. Slope is negative, which means acceleration is negative. And, did you guys give me the third answer?
13 to 15.
13 to 15. Okay? Okay. So, I'm just going to, I'm running out of time, so 9 to 11, and I'm going to say since that one was what? Velocity is greater than 0, and acceleration is greater than 0, right? The others were 3 to 6, and 13 to 15. Oh my goodness. And that's because velocity was less than 0 and acceleration was less than 0. During what time intervals, if any, is the acceleration of the particle positive? That's going to be when velocity is increasing, and that's 6 to 11. So, okay, guys, make sure you do the homework.
How many pages? Oh, awesome.
Is it short?
Nope.
No?
4 pages. Number 12 was terrible. Yeah. Hey, no, I should have.
Okay.
Don't throw them away.
No, I'm gonna throw them away.
No, please don't. No.
Okay.